Good day to you, and I welcome you specially to another educational video on research. And I just want to use this particular video to make you learn the choice of a particular inferential statistics. There's another video on inferential statistics which I would want you to watch as soon as you is premiered. But this particular video is actually designed to make you know the correct choice of statistical analysis that you would use when you are trying to do your research. It is the type of research that you are carrying out that actually determines the choice of your data analysis. For example, if you are to think about food, nutrition, you hardly have opportunity to actually determine the rate at which you will do a particular thing or how you will do it without considering some factors. So if you are comparing, as it were, two individual groups, two independent groups, let's say you did a one shot case study. You gave a group a particular teaching method, the other one will be one short case study with a control. Let's give, but you don't have a pre-test, just post-test alone. You now give a group achievements, you give them a method of teaching. The other group, you did not give them that method of teaching, and you give them a post-test. So you are comparing, group comparison. You can see the first one in the video that I'm sharing with you talks about group comparison, and within the group comparison we basically have when the number of independent variable is 1. For example, the categories is just one group. Maybe let's say in a class you want to consider gender, so that gender is 1, but the number of categories of gender is 2. So you want to check whether there is a difference in achievement. So your independent variable is gender that is operating at 2 levels. Then the number of dependent variable, when it is 1, you don't have any control variable in this instance. And the type of dependent variable is categorical. There is another video on types of variable. Categorical variable, that means it's just a label. It does not have 1, 2, 3, 4. And your dependent variable must be continuous. I advise you watch the video on the dependent variables and the continuous variable, the scales which variable do exist. As soon as you watch that video, you will have understanding on the subject matter. So we have the categorical variable. That means the gender is in category, male and female. But the achievement, which is the dependent variable that depends on gender, is either on a scale of, maybe this test is over 10. Somebody can score 1, 2, 3, 4, 5. So it is continuous. And the distribution is normal. I have said it that most of the parametric statistics like t-test is a parametric statistics. It is actually given in such a way that the participants are spread. They are spread on a scale, and the scale is that the people that perform very well, they are few. That's normality. The people that perform woefully are also few, but the people in the average middle section, they are more. So t-test is what you will use, because your independent variable is 1, although there are 2 categories of that independent variable. The point is that is when you will use the independent variable. So if I may correct what I have here, 1 independent variable, number 1, but with 2 categories, like gender. That's when you use t-test. So t-test is suitable within that frame if you would love to do t-test. So let's go to the second one. In that one, you also have 1 independent variable, if I may put it like that. 1 independent variable, but this time around, but with more than 2 categories. So for this, when you have this situation, let's assume you are a school teacher, and within your school we have the 3 ethnic groups that are coming there: the Hausa, the Yoruba, and the Igbo. And you want to consider whether the ethnicity, so the independent variable is 1, but it has 3 categories. We have the Hausa, the Yoruba. You want to consider whether ethnicity is affecting student achievement, or you give the parents, you want to see the marital status of parents: married, single parents, divorced parents. So when you have the dependent variable is marital status, but it has categories under it. So those sub-categories, when they exceed 2, and you still have 1 dependent variable, like let's say this is also achievement, and you want to check whether the type of ethnicity or whatever it is affecting the achievement of students. The type of score, your independence, is also categorical in this situation, while the dependent is continuous. The normality is also valid. I have explained it before. The type of analysis, the statistic that you will do, is also the analysis of variance. That's what is suitable in this circumstance, and it is also parametric. So it's a comparison of more than 2 groups in terms of outcome. The first one, which is t-test, comparison of 2 groups in terms of outcome. Now, the next one is the analysis of covariance. The analysis of covariance. This is the type of analysis that we usually carry out in an experimental study, most especially the one we do in education, that is the pre-test, post-test, quasi-experimental research. In this type of research, you have a pre-test and you can have treatments. The treatment can have one group that is taught in a particular way, another group that is taught in a particular way. So when we have a pre-test and a post-test, we are comparing the two. We will now need the analysis of covariance. The purpose of the analysis of covariance is that it allows us to consider the pre-test and the post-test as well as the group. So it will factor in the pre-test and the post-test using the pre-test as a covariate. That's what we call ANOVA. And in most of the education research, that's what we do when we are trying to check whether a particular strategy is working. The covariate makes us to partial out. The pre-test, which is usually used as a covariate, usually helps us to partial out the initial disparity that may exist among the group, as it were. So that's when we use ANOVA. So whenever you ask yourself this question, you'll be able to answer correctly. Oh, what is happening here is the categorical. You can see consistently the independent variables are categorical, while the dependent variable is continuous, like achievement score, student interest, attitude, and so much. Even in nursing, it could be blood pressure, whatever it is that you have, and the categorical variable may be a type of drug, a type of exercise, and all of that. That's what we do. Now we have left. You can see that the pair that we have been dealing with had been one categorical, one continuous. The dependent is always continuous and the other is categorical. But now we have left that one. This is association between groups, but you can see that both of them are categorical. For example, let's talk about the state of origin and let me put it like this: student ethnicity and their parents socioeconomic status. Let's assume ethnicity is also divided into three: Hausa, Yoruba, Igbo, and socioeconomic status is also categorized into high, low, medium. So the dependent variable is the socioeconomic status, and it is divided into three. Then when that is the case, the independent variable is the ethnicity. So we want to check whether ethnicity affects socioeconomic status. You can see that both of them are categories. They are in categories. And this is not a normal curve. So this is an example of non-parametric statistics. This type of statistics is non-parametric. And when you have this type of statistics, when you have this type of data, the type of statistics that you are supposed to run is the chi-square analysis. It is non-parametric. It does not make use of mean and standard deviation, as it were. Then after this, we could talk about the one that I said is not inferential. It is also descriptive. That's the Pearson product moment correlation. You can see that chi-square tells us association between two variables measured by categories. But this time around, we now have continuous, and both of them are normal. Let's say we want to see the relationship between attitude and achievement, interest and growth. both of them are continuous, and the independent variable is not categorical, it's just one. In that case, we will run what we call a Pearson product correlation. It tells us whether they are associated. Now, finally, we have a relationship between two or more independent variables. This is not an experimental, it's not usually used in experimental study, but non-experimental study, descriptive survey. Let's assume that we want to check 6 factors of student. Let's say gender, age, parental involvement, parental income, and distance from school, and all other another factor. And we want to check whether this factor actually influence their achievement in school. The point is that we can run a multiple regression. That means we have more than one independent variable, and these independent variables are on the continuous scale, while the independent, which is the achievement of those students, is in the continuous scale also. So as a result of that, we will do a multiple regression. It helps us learn about relationship between several predictor or independent variables. It provides relative prediction of one variable among many in terms of the outcome. So multiple regression will give us the joint contribution of our 6 variables to the dependent measure, and it will equally give us the result of the individual contribution. Thank you very much, and see you in another video.